Let's begin the second part of the Horticultural Entomology series. And in this section, in this class, the focus is going to be insects and some mites that are associated with food crops. So mostly fruits and vegetables. It could be herbs as well. And we'll organize this in 5 sections, modules, and there'll be a kind of theme in each one of these. In Module 1, I'm going to go through a brief review of the types of injuries that insects cause and bring up some terms that we're going to use throughout this. And most of the focus in the first section here, this first module, is going to be on things that affect plants early, maybe prevent plants from even emerging or damage seedlings or young plants. And in particular go into 2 that are fairly common in some parts of North America that have cryptic habits, meaning you don't see them, they feed at night, but they cause fairly similar kinds of injuries, slugs and European earwig. Not a problem for some of you who listen to this, but they certainly are in much of the United States. So the kinds of things that we'll be covering would be stand loss and seedling injuries. That's what we're going to cover first. And later, as plants get established, insects will be feeding on them. And at this point, they could be causing injuries that may directly affect the part of the plant that ultimately we're going to sell, or a part of the plant that contributes to the growth of that. So here we bring up the terms indirect injury and direct injury. Indirect injury would be where they're feeding on a part of the plant that you don't sell, the leaves of a tomato. A direct injury would be the tomato itself, and if something was feeding on the tomato itself, that would be a direct injury. But many of these are causing indirect injuries. They're not feeding on the part of the plant that we market. They may reduce yield by chewing foliage and losing photosynthetic area, or sucking insects like aphids or leafhoppers may reduce the amount of fluids in the plant, so there is some measured yield. But direct injuries are the ones that often require the most intensive treatment, because if they get into what you're trying to sell, then often it has to be downgraded or maybe culled. So, for example, picture on the right is an apple damaged by the caterpillar of the codling moth, the number 1 pest of pome fruits like apples and pears. And a tremendous amount of attention has to be given to try to control that insect. On the left is an insect that's got 2 common names. We'll revisit this. It's called the tomato fruit worm. It's called the corn earworm. You might find it in the ear tip of sweet corn, and we call it the corn earworm. Might be inside a pepper fruit or a tomato fruit, and we call it the tomato fruit worm then. And then I also want to bring up this idea of cosmetic damage, because this is very important in production of fruits and vegetables. Too important, unfortunately. But in this case, we're talking about injuries that are produced usually by insects, thrips, small beetles, that cause blemishing. They don't affect yield, they don't affect the taste or flavor, but they affect the appearance. And a classic example would be thrips on various kinds of crops, including the picture here on citrus, where we have thrips on citrus that don't hurt the crop directly, but you get a few in the flower, and then that manifests itself as a little scar on the fruit, and then you put that in the supermarket, and people pick it over and avoid it. Or you grow some kind of brassica, some sort of mustard like arugula here, and you get little holes in it. There's flea beetles. The leaf is almost entirely perfect, but there's little holes, and that can be a market defect. And these cosmetic kinds of injuries are real drivers for a lot of the insecticide use that we have on fruits and vegetables. A lot of too much insecticide use is applied so that we avoid having, heaven forbid, these small blemishes on what gets marketed. Another thing we use a lot of insecticides for in fruits and vegetables is just preventing an insect from being on the plant when it's marketed. This is mostly an issue with leafy vegetables, and you have aphids, you have thrips, very common on these plants. They can be eliminated by use of insecticides or some other kinds of approaches as well, but often, there's some on the plants, and they don't hurt the plants. They're just on the plants, and so that's how we do a lot of insecticide use on these crops to, heaven forbid, prevent there ever from being thrips in your lettuce, or a couple of aphids in your spinach. And then a separate issue will be where the insects are going to be important not because they damage the plant themselves, but because they're capable of carrying a pathogen. They can act as vectors, and there's some very important insect vector diseases of vegetable and fruit crops here in the United States, and we'll talk about those separately. In these cases, again, the insect's not important, but the insect as a vector can be very important. So citrus greening is a devastating disease of the citrus crop, particularly down in Florida right now, and it's transmitted by the Asian citrus psyllid. The citrus psyllid's not very damaging on its own, but if it's carrying the pathogen to produce citrus greening disease, it's essentially can cause the plant to ultimately die. Aster yellows is a disease transmitted by a leafhopper. The aster leafhopper produces no visible injury to the plant, but if it's carrying the pathogen that produces aster yellows, carrots or lettuce or many flowers can be infected with that pathogen. So let's just start with the stand loss issues, and some of the big ones that would be involved in early season issues would be cutworms, flea beetles, and root maggots. And I want to start with the root maggots. So these are going to be fly larvae. The term maggot is applied to fly larvae. So there's a typical maggot in the upper right in this picture. Again, if you remember, most Diptera larvae do not have a head. None of them have legs. So it's a stripped down maggot with a pointy little head. And one of the groups is called the root maggots. This is in the genus Delia, and the adults are fairly small, medium small, grayish flies, smaller than a housefly, and they develop on below ground parts of plants. So a lot of them feed on organic matter, but just decaying organic matter, but they also may tunnel into seeds or into roots of vegetable crops. And the most widespread of these is an insect called the seedcorn maggot, and this is mostly a problem on large seed, warm season kinds of plants. So we're talking about things like corn, we're talking melons and cucurbits, we're talking about beans. And I call this the bane of the overeager gardener because this is an early season kind of insect, and often it becomes much worse if you plant a little earlier than you should, and we'll get into why that is. But a very, very widespread insect in North America. But often people are unaware of it. All they see is, or don't see, is their plants coming up in spring. They planted something and nothing comes up, or comes up looking injured in some way. So seedcorn maggot, these tiny little grayish flies, they emerged very early in spring, one of the very first kinds of insects you can see out and about. And this and one of the other root maggots that we have, all of them can develop at cool temperatures. We talked a little about the idea of a base temperature and degree days, and we're going to come back to that. So the base temperature would be where an insect ceases to develop. And for most insects, it's 50 degrees Fahrenheit, around that. And for the maggots, root maggots, it's 40. So they can be active at 40, 45 degrees Fahrenheit. Most insects cannot. They are particularly damaging early in the season in situations where there's moist soil with decaying organic matter. This is a favored egg-laying site, and if you newly turn soil in spring, it becomes very attractive. So if you had incorporated fresh organic matter or tilled in a green manure crop, At that point, it becomes very attractive to these adult flies who will then lay eggs there, and anything you may plant immediately after that is very likely to be damaged. So they may feed on the decaying plant matter, but if you then go in and plant your corn or your beans or your pumpkins into that site, there'll be a lot of maggots in there, and they may take out the seeds of your crop as well. So the larvae, when they're causing damage to crops we worry about, could be developing in the germinating seeds. So here we can see a couple seed corn maggots in bean seeds, and if this happened at an early stage, the bean may be so riddled and then invaded by decay that it just doesn't even emerge. And they also can then later tunnel into the base. So in the picture on the right, you can see some internal tunneling, and that would cause the plants to wilt. But a very common symptom on beans, and something I just saw a week or so ago in my garden because I planted too early, is what's called snakehead beans, where the beans come up and the growing point's gone, and that's because it was killed underground by seed corn maggots, and oftentimes that is a plant that won't function. It can't live. It can't produce a new growing point. So these would be various kinds of injuries you might see from seed corn maggot just to beans. And again, that's not the only crop that it attacks. Obviously, corn would be another. But again, curling, snakehead symptoms where the growing point is killed, some twisting, and again, many of them don't come up because they were killed below ground. So conditions that favor seed corn maggot injury are, as I mentioned, the presence of fresh decaying organic matter in the seed bed. So fresh organic matter, not well-decayed organic matter. And again, recent tillage, if you just incorporated a green manure crop, that is just a magnet for these things. They do better in moist soils, so if it's quite moist in spring, that's another risk factor. And then affecting the plant, the crop, more than the insect itself, is cool conditions will retard the growth of the kinds of plants we're talking about. Beans, corns, cucurbits like pumpkins and squash, these are all warm season plants that require minimum soil temperatures of 60 and above is better. And if you plant it in cool soil, they don't grow. The maggots do well because they can develop at quite low temperatures, but the plants don't. So that's why I call it the bane of the overeager garden. You plant your plants too early, the seeds sit there for longer than they would otherwise if you had a warm seed bed, and they get hammered. So how do you avoid it? Take those into account and just avoid those practices. So if you're going to use organic matter, it should be thoroughly decayed, incorporated in the fall rather than in spring. If you're going to till in the spring, wait 10, 12, 14 days or so before you then plant, because recent tillage does make it more attractive to oviposition. Avoid practices that keep it very moist. I mean, obviously it needs to be somewhat moist, but if you have some control over this, don't keep it wet all the time. And plant it in a warm, firmed seed bed so it can get up and out as fast as it can, so it can outgrow those injuries. Now, a couple things that are of interest with these root maggots, and one of them, and this is a little side note, is they get infected by a kind of fungus that is not uncommon, called the fly fungus, and it is a specific species of fungus that attacks flies of this group. And when a fly becomes infected, the adult fly will often perch at a high point in the landscape. It might be in the top of a plant, or maybe a pole that you've got in your garden or whatever, and then it dies there and it sticks to the plant or sticks to whatever it's on. And then later, as the conditions get moist, spores will erupt and the spores will blow all over from the body of this infected insect. So if you see stiff, dead flies on a plant in spring, that's one that's been hit by a fly fungus. Stiff, dead insects sticking to plants, that's probably a fungus. Later we'll show you one that does the same thing to grasshoppers. different fungus, but same kind of behavior. Here's one that the fly actually died on my window of my indoor greenhouse, and so you can see the fly right there, and then perhaps not so much in this picture, but to the left in that lower right, you can see the little spray of spores. So here's a couple other pictures. So sprays of spores that ultimately came out when it was a very wet, humid period. A storm event came through, became humid, and spores erupted. Anyway, something to watch for in the garden. Seedcorn maggot may also damage other kinds of plants, and they could be damaging plants that are seedlings that have come up. So we have a picture there of maggots in the base of a broccoli plant. Where the plant I've seen them mostly in, because I've worked with it a lot, is onions. So an onion plant may come up and then wilt, and there may be a maggot in there. And in our area, it's usually seedcorn maggot. But the next one we're going to talk about is onion maggot, which could also do that. So onion maggot, same genus, Delia, but this is just associated with allium species. So onion and related plants, maybe garlic, leeks, shallots, things like that. But allium crops. Much less widespread in North America than is the seedcorn maggot, but quite important in certain production areas from New York to California. It has 3 generations. The first generation's adults emerge in late spring, later than the seedcorn maggot, and the flies will try to find a host, and it has to be some allium, some onion or relative, and they lay their eggs on the soil around the base of these plants, these host plants. The eggs then hatch, the larvae then go in, and then develop in the base of the plant. There are 3 generations produced of this, as I mentioned, and this is an insect that in commercial production is often tracked by using degree day models, as we've discussed before and we'll mention several times again here. Insect development is often predictable if you track temperature, because the rate of development is related to ambient temperature around their body. They're cold-blooded. So use degree day models, with a degree day being 1 day of temperature of 1 degree of temperature above the base. If it's 51 degrees for an average day, and they get a base temperature of 50, that's 1 degree day here. So there's degree day models that have been developed, and in seedcorn maggot, or excuse me, in onion maggot, this shows some data from New York in a couple different locations. The degree days calculated in both Fahrenheit and Celsius centigrade. You can capture these root maggot flies on yellow sticky cards, very easy. I mean, you put out a yellow sticky card in a garden, you will get a lot of these, but the usefulness of these is not huge because they're so difficult to identify. You get a bunch of these gray flies, but it could be 3-4 species on this card. So it could be. This is very useful if you got the lab and you can go back and look at each one on those sticky cards. But you'll have a mixture in most settings. So the damage by the larvae, the first generation, is often the worst. This will get into the plant. It'll get into the base of the developing onion and often will cause it to wilt. Now, I showed you that picture in the upper part here in this slide here, and that's actually seedcorn maggot, but onion maggot would do that as well. These can be identified, but again, it's a microscopic feature that you'd have to look at to separate an onion maggot larva from a seedcorn maggot larva. Later in the season, the plants are a little more developed. They may not kill the plant, but they may damage the plant by making a wound in the side. And if you get a damaged spot like that, that can be a market defect, but it also can be an entry court, a wound that allows certain pathogens to move in, certain decay fungi or bacteria. So that's another issue with onion maggot. So in commercial production, onion maggot can be managed quite well if you can rotate, but you need to be able to rotate at least half a mile from a previous crop. These are not strong flying insects, and they're limited to allium, but many farms aren't big enough to have the luxury of being able to go 5 miles down the road to plant their onion crop. But if you could, this is an insect that if you have sufficiently distant rotations, you can largely manage this insect. You could do it if you had a host-free period for that at least extended through most of the year, and ideally for an entire year. By a host-free period, meaning there are no allium in the area, not just onions, but other plants that might support it. You could delay planting. You use these degree day models, and you can get an idea of when the first generation has passed egg laying, and then you get your planting scheme in to avoid that. Now, in this case, that may also result in yield loss, because onions you usually want to plant a little early. In a garden, covering plants with row covers throughout the period of that first generation, that's probably the best thing for you to do. If you can eliminate that first generation from developing, then that should have a big impact on it not being in high numbers for the rest of the season. There are insecticides that are used. These are used in commercial production. They're not available for non-commercial production. But these row covers, we'll talk about this a couple of times when we're talking about vegetable insects. If you're not familiar with them, they're these lightweight fabrics or certain kinds of netting, but some kind of cover that you put over the crop that is sufficient to prevent the insect from reaching the crop. And often these are light, and they rest right on the crop, and the crop can grow up through it. You have to seal the edges. The covers should be in place before adults are laying eggs if you're going to use this. And these are pretty early, but you can get an idea of when they're going to happen in your area by looking at degree day models. If you've got a small planting, the edge has to be buried at least 4 inches away from the plant, maybe 6 inches away from the plant, because the maggots, if the eggs were laid right there, the maggots might be able to move about 4 inches and find the plant still. So don't cinch it right next to the base of the plant. And make sure that the adults aren't emerging from underneath that. If you put row covers over a bed of onions, and you had onions there last year, there's probably pupae of onion maggot in there, and they'll just come up and they'll have free reign underneath your row cover. But this is something that many people could use, particularly in a small garden, but it's also done in large plantings as well. And then an insect that I've never worked with personally, it's found more in northern areas, northeastern part of the country, in particular southern Canada, is cabbage maggot. And this limits its damage to various cabbage family plants, mostly brassica something, but not only. So again, another Delia species. So cabbage maggot emerges early in spring. In New England, one telltale sign that is used for predicting when it's going to come out is the time a very common weed comes out, Barbaria vulgaris, wintercress, yellow rocket. When that starts to bloom, that's about the time cabbage maggot adults are out. This kind of thing that I'm talking about here, where you have a plant that is associated with an insect event we call phenological indicators. So first flight of cabbage maggot being associated with bloom of wintercress, yellow rocket would be a phenological indicator. When we get these phenological indicators, they can be nice shortcuts to use for getting timing. Anyway, same situation. The adult lays eggs around the base of host plants, and the host plants are mustard family plants. There's a lot of weeds that are mustard families. Those don't seem to be very important, but mustard family plants that we grow, and that's cabbage, broccoli, turnips, radishes, cruciferous vegetables in the Brassicaceae family now are susceptible. So they lay eggs in the soil. I think you maybe see some eggs in that photo in the lower right with the arrows pointing to it. And then the larvae tunnel into the roots of the plants, and the effect on the plant will often be retarded growth, maybe wilting if it's been damaged. In some extreme cases, it might be death of the plant, but often the plant is fairly well established, and these are going to cause injuries that will take out some of the roots, and again, the plant will be slow in developing, and yields will be reduced. This one has a fourth generation, so these are growing. GDD is growing degree A for these key maggot fly pests, all of which have a base temperature around 40 degrees. And so again, bringing up this idea that these are predictable. Later generations can be damaging to late season fruit crops like turnips or rutabagas. So for cabbage maggot, crop rotation, again, not a strong flyer, but strong enough to move maybe a half a mile. Don't overwinter susceptible crops. Not uncommonly, people will overwinter maybe kale or some root crop, turnips and the like. And if you do that, then that will produce a reservoir of these cabbage maggots that have something to feed on through the winter too, just providing a living bridge. So that's not a great idea. You can cover the plants with those row covers during the first generation, and insecticides again are used in commercial production, although they're not available for home gardens. And then getting near the end, just one kind of different fly, since we're on this idea of little tiny fly larvae that get into roots, there's a situation with something called the carrot rust fly. Much smaller kind of fly, and only is associated with plants in the carrot family, mostly carrots. By the way, the family name, I think you can see that, is Psyllidae, P-S-I-L-I-D-A-E, and this is going to be confusing because later we're going to talk about Psyllidae, go to the bottom of this slide, P-S-Y-L-L-I-D-A-E, and that's a very different family of insects that we'll talk about with the citrusillid and the potato-tomato psyllid. Rust fly has 3 generations produced per year, and control is fairly similar to some of the others we've talked about, rotation and floating row covers. Adults lay their eggs in soil around the base of plants. The larvae feed on the roots of carrots. One last thing, and we're done here, is we've been showing you pictures of different fly larvae you'll find associated with below ground stages of various kinds of garden vegetables or commercial vegetables for that matter. There are other flies you will see, and in particular there's lots of kind of fly larvae that you will see if a plant has got some damage, if it's got some decay, if something chewed on it or it is decaying from some pathogen. You can find fly larvae in there all the time, but those are secondary. So like a housefly would be a secondary pest on a vegetable crop. It wouldn't invade and hurt the plant on its own, but once there's some damage, it'll move right in. So you have to be careful with what's a primary pest that's causing the damage and what's secondary. So that's it for this first one, and we'll continue with these seedling, early season insects for the rest of this module.